Every electron in the universe carries exactly the same charge, not approximately the same exactly. Measure the proton's charge against the electrons and the two match in magnitude to better than 1 part in 10 to the 21. Nothing in Maxwell's equations demands that. A smooth field takes a continuum of values. There is no reason on Earth a droplet should not carry 1.5 units of charge. And yet Millikan suspended thousands of orbs against gravity. Read off the charge from the field it took to hold each one, and the numbers did not scatter. They landed on a ladder. 1 rung, 2 rungs, 3 rungs. Never between the rungs. That is a scandal hiding in plain sight, and the standard model does not fix it. The standard model puts the charges assignments in by hand and merely checks that the anomalies cancel. So where does an integer come from in a world made of smooth continuous fields? Here is the idea this chapter turns on. Draw a loop, walk around it once and watch a phase, an angle, a clock hand turn as you go. When you get back to where you started, the hand must point where it pointed before, so it has turned a whole number of times. Once, twice, never 1.5. You cannot half-wind a loop. That integer is not put in by hand, it is a count. And the claim of this chapter is that the count is the charge. One thing before we begin. Advaita Chakra Theory is a speculative, exploratory framework, not established, peer-reviewed physics. Much of what follows is honest conjecture that still needs validation. Watch it in that spirit as ideas to test, argue with, and refute. Let us be precise about what needs explaining, because it is easy to aim at the wrong target. The puzzle is not how big the electron's charge is. The puzzle is that charge is discrete at all. Why should it come in whole units when the field that carries it is smooth? And once you phrase it that way, the answer is almost forced by elimination. A smooth field has no integers in it. Its amplitude is a continuum. It can take any value you like, and there is nothing in a continuum that knows how to count. So the integer cannot live in the amplitude. It has to live somewhere else. The only place an integer can hide inside a continuous phase field is in its topology, not in what the field's value is anywhere, but in how the field wraps around. That is the whole strategy of this chapter in one sentence. Now, the substrate we are working on. Since chapter 1, this series has had one ingredient, a lattice of little rotors, clock hands, each one a compact angle. Compact means it lives on a circle. The value 2 pi is the value 0, and there is no way to tell them apart. When the lattice locks, a collective phase emerges across it, and that emergent phase inherits the compactness of the rotors underneath. That inheritance is axiom A2, quantized rotors, and it is going to do all the work. Everything that follows is a consequence of one fact: the phase is an angle, not a number. Before we find the answer, we have to kill the obvious suspect, and this one matters because the theory itself got it wrong once and had to retract it. Here is the temptation. Textbook electromagnetism is built from a vector potential, and a phase gradient looks exactly like a vector potential. So, take the gradient of the matter phase, call it the electromagnetic potential, and read off a field strength. It is the most natural move available, and it fails, instantly and completely. Because the field strength is built from the antisymmetric part of a second derivative, you differentiate in one direction, then the other, then subtract. And for any smooth field, partial derivatives commute. The two terms are identical, they cancel. The field strength is not small, it is not approximate, it is identically zero everywhere. For every smooth single-valued phase you can write down. A pure gradient carries no curvature, so there is no sound photon hiding in the matter phase. The real photon of this theory is a different object entirely, the one unlifted Goldstone mode from chapter 3, the collective sway that costs no energy, promoted to a genuine Maxwell field in chapter 23. An earlier draft of the corpus posited the matter phase gradient as a second, propagating gauge field. That identity retires it, and the corpus states the retraction plainly. The theory keeps only what survives its own identities. And notice what the retraction leaves behind. If the smooth part of the phase contributes nothing at all to electromagnetism, then whatever charge the phase carries must be encoded in the one thing that identity cannot see, a failure of the phase to be single-valued. So we go looking in the one place left. Take a closed loop and integrate the phase gradient around it. If the phase were an ordinary single-valued function, that integral would be 0, you come back to the value you left. But the phase is an angle. It only has to come back to itself modulo 2 pi. And if the loop encircles a point where the phase is undefined, a defect, a place where all the values meet and no angle can be assigned, then the phase can accumulate a whole number of extra turns. Define the enclosed charge to be that turn count the loop integral of the phase gradient divided by 2 pi. 3 facts force it. First, gauge invariance. Relabel where you call 0 on the phase, add any smooth single-valued function, and the integrand changes, but the loop integral of a gradient of a single-valued function is 0, so the count does not move. It depends on the defect, not on the bookkeeping. Second, integrality. The phase is a map from the loop, which is a circle, into the target angle, which is also a circle. Circle into circle. Those maps fall into classes labeled by the integers. That is the fundamental group of the circle, and it is the whole of the argument. The count is forced to be an integer by the compactness of the rotor. No monopole required. Third, conservation. An integer cannot change by continuous local evolution. To change it, a defect must meet an antidefect and annihilate, or a defect line must cross your loop. Charge conservation is not another accident of a symmetry we imposed. It is topological bookkeeping the substrate cannot violate smoothly. Note the tone of that argument. We did not define charge and then discover it was conserved. We asked what conserved label a compact phase can carry, eliminated everything smooth, and the winding was the only survivor. The winding is not an abstract label pinned to a diagram. It moves things. A defect sitting in a field with stiffness rides its own Goldstone gradient. By the guidance law of chapter 27, velocity equals h bar over mass times the gradient of the phase. Integrate that velocity around a charge n defect, and the gradient integral is the winding we just computed, so the circulation comes out quantized. It equals n times Planck's constant over the mass. And I want to be exact about credit, because this is the chapter's one squarely standard equation. That is the Onsager-Feynman quantum of circulation of a superfluid vortex line from 1949 and 1955. Textbook condensed matter. ACT does not derive it, ACT relabels it. And the relabeling is the point. On this substrate, the electric charge and the superfluid circulation are the same integer. Read two ways. Read as a phase winding, it is charge. Read as an advected circulation, it is a vortex. Because the vortex physics is standard and experimentally grounded, the charge inherits an actual mechanism rather than a definition. Now here is the part that made this chapter worth filming. Compare that winding to the one chapter 27, read off the arriving electron in the double slit. Identical formula, identical integer. There the topological label was what made the arrival a single indivisible click rather than a smeared out density. Here, the same label makes the charge a single indivisible unit. One winding does both jobs. That is the spine of this theory surfacing again. Matter and charge are not two substances. They are one topology of one Goldstone field. The particle that clicks is charged because it is a vortex, and it is a vortex because it clicks. Now the objection that lands immediately, and it is the right objection. Quarks carry charges of plus or minus 1/3, plus or minus 2/3, but a winding number is an integer. There is no such thing as a 1/3 homotopy class, so either the quarks break this chapter, or the chapter owes you an account. Here is what the chapter actually claims, and please hold me to the exact wording, because it is narrower than people usually assume. The isolated, gauge-invariant winding of a single emergent circle-valued phase is strictly integer. Full stop. The observed fractional charges are not fractional windings at all. They are the eigenvalues of the electric charge operator, the third component of weak isospin, plus the hypercharge, and those hypercharge assignments are fixed by requiring the anomalies cancel across the 5-multiplet spectrum. That is the Jeng-Marshak result, and this book relabels it in chapter 21. It is not derived in this chapter. Fractions in thirds are a statement about how the one integer winding distributes over the internal channels of a composite site, not a violation of the integer. And confinement then keeps the thirds from ever showing up in a Millikan drop in the first place. So the honest summary, the integer survives untouched, and the thirds are its bookkeeping across channels, with the bookkeeping itself imported from anomaly cancellation, not produced here. The tempting shortcut is to just allow 1/3 windings. The chapter rejects it explicitly, and rightly fractional windings break the homotopy classification, and with it the entire guarantee of quantization. You would be trading the one thing you actually derived for the one thing you wanted to fit. Let us do it with actual numbers, because on a lattice this is arithmetic a schoolchild can check. Replace the loop integral by a sum around one elementary square, a plaquette. For each link, take the phase difference and wrap it into its shortest sense, between minus pi and pi. Now assign 4 corner phases going anticlockwise 0, 90 degrees, 180, 270. The 3 forward links each step by 90 degrees. The closing link runs from 270 back to 0, which wrapped into its shortest sense is also plus 90. 4 steps of 90 is 360, 1 full turn. Divide by a full turn, and you get exactly 1. A unit charge sits on that plaquette, and the arithmetic returned an exact integer with no rounding slack whatsoever. Reverse the corner order and the same steps give -1 the antiparticle. For the circulation of that defect in the electron channel, Planck's constant over the electron mass is 6.626 times 10 to the minus 34 divided by 9.11 times 10 to the minus 31, about 7.27 times 10 to the minus 4 square meters per second. A charge n defect advects with n times that. 2 coincident unit defects present a total of 2 to any encircling loop, because homotopy classes simply add. A +1 and a -1 brought together present 0 and are free to annihilate. That last fact is charge conservation, done by counting, and it gives a falsifier with no wiggle room. Prediction 1: no isolated free charge is ever a non-integer multiple of the elementary charge. A confirmed free fractional charge would falsify the winding outright. There is no fractional homotopy class for it to hide in. Decades of free quark searches return null, so the prediction stands. Prediction 2: charge changes only by defect-antidefect processes, never by smooth leakage. Now the passage that this series exists for. What did we not get? First and largest the unit, the winding equation fixes that charge comes in integer multiples. It says precisely nothing about the size of one multiple. The physical value of the elementary charge, typically the structure constant, the 1 over 137, is not derived here. The corpus is explicit. It is an input blocked on an underived charged mode spectrum, and when the papers run the coupling they get roughly 1 over 85 instead. That is the wrong order. It is stated as the wrong order, and chapter 36 records the verdict as input. The honest statement is buys you the quantization of charge for free and buys you the unit not at all. Second, the fermion. Push the compactness 1 turn further and build a field out of the half angle, a 2-component object whose entries carry half the phase. Turn the underlying phase through a full circle and that object comes back with a minus sign, the defining signature of a spinner, exactly the electron's 4-pi periodicity. It is real and it is suggestive, but it is a seed and nothing more. The masses, the chiralities, the number of species, none of it is computed from that half angle. The corpus retracts any claim that it is, and labels it asserted. The honest home for that calculation is a Volovic Fermi point argument in chapter 26, promoting a protected node of the substrate's dynamical matrix into a genuine Dirac fermion. Until that returns a spectrum, the half-angle spinner is a promissory note. And third, to say the quark thirds once more in the negative, this chapter does not derive the observed charge spectrum. It derives that charge is an integer. The pattern of thirds is imported from anomaly cancellation in chapter 21. This chapter derives the charge of matter and only seeds its spin. Verdict. Charge quantization on this substrate is automatic and it is integer, and the corpus calls it the deepest single success of the matter sector. The argument is short. A pure gradient carries no field strength, so the smooth part of the matter phase contributes nothing to electromagnetism. That leaves only the non-single valued part, and the winding of a compact phase around a defect is gauge invariant integer by homotopy and conserved because integers cannot drift. Where Dirac needed a hypothetical monopole somewhere in the universe to get the same integer, the compactness of the rotor does it directly, and no monopole is required. The quantization is cheaper and more certain here than in the textbook. What the chapter borrows, it says it borrows. The quantized circulation is Onsager and Feynman. The homotopy classification is standard defect theory. The quark thirds are Jeng-Marshak's anomaly result relabeled. What is genuinely new as stated is none of those individually, it is their common origin. One compact goldstone phase, whose smooth part carries no photon, and whose topology is at once the click of the double slit and the charge on Millikan's drop. And what remains unpaid is stated plainly: the unit is an input, and the fermion is a seed. The derivation is clean exactly where it is topological, and thin exactly where it is dynamical. Next we have a charge. Chapter 20 gives it a companion, the lifted goldstone that becomes mass, and then puts the two together and builds a hydrogen atom. A word of acknowledgement. This work was inspired in part by the non-dual teachings of Sri Narayana Guru, that the creator, the creation, and the substance of creation are fundamentally one. Symbols from the Hindu tradition, the Sudarshan chakra and the Shivalinga, suggested the analogies behind the chakra model. They are acknowledged as philosophical and symbolic inspiration. The physics stands on its own. Thank you for watching. If this made you think, please like the video and subscribe. It genuinely helps this work reach the people who will argue with it properly. And do leave a comment, tell me where you think I am wrong. Every chapter in this series names its own kill tests, and the objections are the point. The book and the next chapter are linked below. Until then, one substance and how far it reaches.